Okay, so yan. Another topic is what we call your biaxial bending, no? So, what is biaxial bending and what its difference sa combined stress? So, sa biaxial bending kasi, the bending occurs in both your major or minor axis. Major be your x-axis and then minor is yung weak axis. So, paano ba sinabi? Example, itong beam na to, di ba ang bending along x-axis, if we have a load dito sa top ng beam, if we have a load there, may tendency itong mag-deflect, di ba? Then that is bending along x-axis. Now, what if, mapapansin nyo, ito yung force. So, this force will have a horizontal and vertical component, di ba? So ang forces na present dun sa beam, wait lang, ganito. Yung force na present dun sa beam, no? So, ang mangyayari, di ba, meron tong component sa along x, sabi natin P. So, ito may PX, tapos may PY. So, kung ilalagay ko yung dito, may PY, tapos PX. Now, yung PY na to, magkukos to mag-deflect siya ng ganito. Yung PX naman, magkukos siya mag-deflect along the ganitong axis. So, ibig sabihin, both sa y-axis saka sa x-axis, meron tayong deflection or deformation. So, this is now what we call your biaxial bending. Unlike your combined stresses now, it's just a combination of axial force saka moment. Ito naman, bending siya sa x and y axis. No? So, it is important that you know how to categorize yung stresses ng mga member. So, yan. Ito kasi, meron tayong force both sa x and y axis na magkukos ng deformation sa x saka sa y. So, ito yung tinatawag natin na biaxial bending or a member subjected to unsymmetrical bending. Another term. Yan. So, ito. So, these are beams bending in both axes or biaxial bending or bending na subjected to unsymmetrical bending na tinatawag. So, when a beam is subjected to a normal load, ito ang normal load, no? Normal siya, normal. And then, normal, di ba, same sa axis, and then causing a bending on the x-axis and a tangential load, ito, 90 degrees, causing bending along the y-axis. Di ba, ito, magkukosto ng bending sa y-axis. Ito naman, bending sa x-axis. It is said that the member is subjected to unsymmetrical bending. So, ito yung illustration. So, if meron tayong load both sa normal and tangential, magkukos siya ng unsymmetrical bending dun sa beam or sa structure. Now, ang analysis for beams subjected to unsymmetrical bending, we have the following conditions or formula that we need to satisfy para malaman natin kung safe. So, first thing na i-consider, of course, is your bending. So, yun. Yung una is bending stress. Now, sa bending stress, kung mapapansin nyo, di ba, the formula for actual bending stress is MC over I. Now, again, MC over I yung ginagamit natin because hindi siya regular shape. Kung rectangle to, 6M over BD squared. But since irregular yung shape niya, so MC over I along x-axis and MC over I along y-axis. So again, di ba sabi ko, your I over C is similar with your S. So pwedeng ito yung equation. Pwede naman M over SX plus M over SY. So depende kung ano yung given. No? So, pero pag ang binigay sa given is both I and S, of course, mas maganda na gamitin nyo yung section modulus since mas maikli yung equation. So, yan, no? So, the load passes through the centroid of the cross-section. Add nyo lang yung bending moment ng X and Y. So, yun yung MX, the moment caused loads acting perpendicular to the X-axis. MY, acting perpendicular to the Y-axis. So, una is bending stress. Tatlo lang yan. Tatlo yung i-consider natin na stress. Second is the shearing stress. Dalawa pala yung condition for the bending stress. Kasi first, if the tangential is at the centroid, no, yung tangential force natin is nasa centroid ng cross-section. Next naman, if yung load or yung tangential load natin is nasa top ng flange. So, kapag nasa top ng flange, you'll notice ang difference lang is yung instead of MC over I, we will have here MC over 2I. And then, if in terms of S, magiging lang namang SY over 2. So, sinubstitute lang natin yung 2I, C, so naging M over SY over 2. So, ito yung equation kapag nasa top ng flange. Again, ang magdi-differ lang is yung sa along the y-axis. Along the x-axis is the same. Similar lang. So, yan. So, first na i-consider natin is the bending stress. Now, the equation to be used depends on the position of the tangential load, kung nasa centroid ba or nasa top ng flange. Next is your shearing stress and then deflection. So actually, tatlo yan. Una, bending. Next is shearing stress. If you'll notice, we're just adding the equation for shear. Diba? If you recall sa discussion natin sa shear, we have the actual shear or the general equation for shear is VQ over IB. So add lang natin yung VQ over IB nung X and VQ over IB nung Y. So i-add nyo lang. And then lastly is your deflection. Now, ang gagawin lang is just get the resultant of the deflection along the x-axis and the deflection along the y-axis. So, kinuha lang yung resultant. Now, what's the equation for your deflection? If you recall in your structural theory, yung method of superposition, di ba, we are using equations for the deflection. So, yun yung mga typical equations for your deflection. So, kailangan yun na yung gagamitin nyo. Kunyari, ang beam nyo is simply supported, subjected to a uniform load. Ano ba yung deflection niya at the center? Diba, 5WL raised to the 4th over 384 EI. So, yun, you need to be familiarized with the deflection or yung equations or formulas para sa typical loadings, tsaka yan, sa mga typical loading, since most of the time, yun lang naman yung binibigay sa mga problem. So, if you want to recall, you may check your structural theory notes or you may look for the formulas or equations sa any structural analysis books for the equation for deflection. So, yun lang. So, bali tatlo yun na. We have bending stress, shearing stress, and deflection. So, what if we have the three? Ang pang-apat naman is we need to check the allowable or yung adequacy. So ano ba yung adequacy? Of course, ang gagawin lang naman natin is we need to check if the actual bending, actual shearing, and actual deflection is within the allowable. Paano ba check kung safe siya? Siyempre, i-compute mo yung actual na bending ng structure and then i-compare mo siya sa actual, sa allowable. So ito, tulad nitong number 1, sa bending, of course, the actual bending stress should be less than the allowable bending. So, ito lang yung equation na gagamitin. Now, for compact or laterally supported shape, if you recall yung equation na to, similar to sa combined combined stresses. But here, ang ginagawa lang natin is ratio nung actual sa allowable, actual sa allowable. I think marami pang nako-confuse, Actual is the small letter F. Allowable is yung big letter, yung nakalagay na. Actual is small letter, allowable is big letter. And then, most of the time naman sa problem, naka-indicate kung allowable ba yung hinahanap or yung actual. So, yun. So, adequacy, ibig sabihin, iti-check natin kung adequate ba or kung adequate ba yung section. So first, adequacy ng bending using this equation. Of course, the actual bending should be less than the allowable. Shear naman, of course, the actual shear should be less than or equal the allowable. Similarly, yung actual deflection should be less than or equal to the allowable deflection. So, pag mag-check ng adequacy ng section, i-compute natin yung actual and then dapat it should be less than or equal sa allowable para masabi natin na safe. Kasi nga, ito yung allowable. Pag nag-exceed tayo dyan, of course, mayroon na siyang deformation dun sa, kunyari, sa shearing. Magkakaroon na siya ng deformation sa shear. So, yan. Yung number 4 lang naman, i-check lang natin siya kung within the allowable ba yung number 1, number 2, and number 3. Okay, so those 3, so bale 4, no, yun yung i-consider natin for us to check if the section is safe or not. Okay, so, yan no, 3. Itong 3, then yung number 4 lang naman, i-check lang natin siya or i-compare lang natin siya sa allowable. Yan. So, tingnan natin. Let's have an example. Yan. So, we have here a W14 by 74 section. Yung length niya is 6 meters. It carries a normal concentrated load of 105 at the midspan and a lateral load or tangential load at the midspan also. So, nasa centroid. Yan, 24 kilonewton. Now, assume that the beam is fully laterally supported and compact. Given Fy is 248, allowable deflection is 1/300. Analyze the adequacy of the section for bending and deflection. So, based on the problem, no, i-check lang natin siya based on bending and deflection, so we don't need to check it for shear. No? And given are the properties of the section. Yan, so ito yung properties. So since bending and deflection siya, we need first to compute for the actual bending. FB is equal to MC over I. Since meron na tayong, ang given is yung section modulus, so ang gagamitin natin is FB is equal to M over S. So since X and Y, FB is equal to M over SX, and then FB is equal to MY over SY. Na? Ito, bending. Then check natin yung adequacy using this equation. Now, according to the compute natin yung moment sa X and sa Y. So first compute moment and then FBX. Moment is PL over 4. The bending stress, substitute the moment and the SX. Similarly, MY, FBY. Dun sa, nakukonfuse, saan ba galing yung PL over 4? So, since this is a simply assumed to be simply supported beam, di ba? Ang simply supported beam with a concentrated load at the midspan. Na pag may concentrated load tayo sa midspan, sabihin natin na that is P. No? And then this is the length L. Pag magdodraw tayo ng shearing moment diagram, ang maximum moment niyan or the moment at the midspan is equal to PL over 4. So instead of drawing the shearing moment diagram, no, you need to be also familiarized dun sa typical maximum moment ng typical sections. What if subjected to uniform load? Diba? Kapag uniform load yan, ang maximum moment mo is, sorry, triangle pala ito. Triangle pala ito. Ito yung parabola. Ang moment mo dyan is WL squared over 8. So, it is important that you know the typical equations for typical loadings. So, in case naman na makalimutan nyo tong equation, ang dali lang naman ang gagawin nyo, ito drawing nyo lang yung shearing moment diagram. Diba? So, gagawin nyo lang is draw nyo yung beam. This is 6 meters, diba? Tapos, ang load natin sa gitna is 105. So, kung 105 yan, ilan to? This is 52.5. Tapos, draw nyo yung shear diagram, tapos moment diagram. Makukuha nyo yung moment sa center, and yun yung moment na to. Diba? So, it is, now, kaya sinasabi natin na advantageous if familiarized na talaga kayo sa structural analysis. Since tong mga to, no, mas madali nyo na siyang makakompute. If, for example, makalimutan nyo tong mga equation. So, balik tayo dito. Then, after makuha yung moment, just substitute m over sx, my over sy. And then, alin yung equation na gagamitin? So, check natin. Based on the problem, no? Ito yung problem. Assume that the beam is fully laterally supported and compact. So, we will use this equation, number 3. Kasi according to the problem, laterally supported and compact, no? So, ito yung gagamitin. Now, looking at this equation, we have already computed the FBX tsaka FBY. Ang FY given siya 248, no? So, we can actually compute the interaction value. Now, for this beam to be safe, it should be less than or equal to 1. No? Kailangan less than or equal to 1 para masabi natin na safe. Tingnan natin. Substituting the FBX and FBY. And then Fy, we have the interaction value is 0.97. So, less than 1 siya. So, this beam is adequate in bending. So, tapos na tayo sa bending. Adequate siya. Yan. Next naman, check naman natin siya sa deflection. Okay, so deflection. So, deflection along the x and y axis, then get the resultant. No, if you're dun sa, para sa adequacy. Now, what is the deflection of a simply supported beam with a concentrated load at the midspan? If you recall, diba, that is PL cube over 48 EI. Now, if ma-recall nyo na sa method of superposition, sa structural analysis, minamorize nyo yan, no? Nung diba, nagtatagal tayo ng redundant, tapos naglalagay tayo ng force, tapos kinocompute natin yung deflection. Yun yung mga typical na deflection formula. So, yun. Sorry, naulit. So, yun, diba? Sa deflection naman, yung resultant ng deflection should be less than or equal sa allowable. Diba? Kapag simple supported sa gitna, that is PL cube over 48 EI. So, ang I natin, since hindi given, diba? I is just equal to S. Yung BF over 2, that is equal to C. Diba? Since S is equal to IC, baka ma-confuse kayo, no? So, since ang alam natin is S is equal to IC, no? So, nire-write lang natin siya, I is equal to S times C, wherein ang C, again, is the distance from the centroid, no? So, this is BF over 2. Yan. Is equal to C, kaya ito naging BF over 2. C kasi yan C. Yan. So, since I kasi hinahanap, yung nasa equation, so kailangan compute natin yung I. And then, PYL cube over 3. So, substitute lang natin yung PY, 24. And then, L cube, that is 6,000. Then, 48 given, 200,000 megapascal. And then, the I that we have computed here, ayun. So, mag-compute natin yung deflection sa x-axis. Now, bakit ba yung ginamit natin is 24? Kasi di ba, ito yung x-axis natin. Sorry, ito yung x-axis. And then ito yung mag-deflect or deflection mo sa x-axis. Ito. So, di ba? So, since yung 24, yung magkukos ng deflection sa x-axis, yun yung i-consider natin dito. Kaya siya PY. Now, kapag sa y-axis naman, ito yung y-axis, di ba? Ang deflection along that axis will be caused by your 105. Kaya, dito, of course, yung consider natin is yung PX naman, so 105. Tapos, sorry, BF pala to, no? Oh, mali ako na. Please correct. BF over 2, ito kasi yung, ito yung C natin, sorry. So, this is BF over 2. Now, yung sa Y direction naman, ito na yung magiging C natin, half. Ito yung D, di ba? Then, kalahati is your C. Ito yung kanina earlier, sorry. By cos nung 24, ito yung BF. No? Yan. BF over 2, ito yung C. So, yan. Sa deflection mo sa x-axis, cos nung 24, ang magiging half or C nitong axis ng x-axis is half nung BF. So, ito, BF over 2. Sa along y-axis naman, na magiging half or magiging C along y-axis is half nung D, kaya D over 2. Yan na. So, then substitute the section modulus of Sx and then Px. Then, makukuha natin yung deflection sa y. Yan. Then after that, we will get your resultant to compute the allowable. Now, based on the problem, given yung equation ng allowable deflection natin should be L over 300 or 6,000 divided by 300, so 20 mm. So the resultant of these two should not be greater than 20. Checking now, the resultant is 12.07, less than 20 mm. So the section is also adequate for deflection. So yun na yung sagot, diba? Since sa problem yung tinatanong, check if the section is adequate for bending and deflection. So based on the solution, no, they are both adequate for bending and deflection. Then let's have another example. No? Ito naman, solve the previous problem if the lateral load of 24 kilonewton passes through the top of the flange. So same problem. Ang ginawa lang is instead of at the centroid, inakyat natin sa top flange. Now, actually yung mag-change lang naman dito is the bending. Hindi naman magbabago yung deflection. So, ang gagawin natin is, ang i-check na lang natin is yung adequacy niya sa bending. So, check natin, no? So, kapag nasa top flange, same yung property ng section. No? Kapag nasa top flange, ito yung gagamitin natin na equation. Case B, no? Load passes through the top of the flange. So, it will be MC over 2I or MY over SY over 2. Now, if you'll notice, hindi magbabago yung FBX. So, copy na lang natin. No? Yan, yung FBX, kinopy ko to from the previous example. Kinopy ko na lang. Now, here, yung MY, hindi din naman yan magbabago. So, copy na lang natin yung MY. Ito. So, based sa previous example. Now, compute natin yung FBY. Ito, MY over SY over 2. Diba? Ito yung FBX, ito yung FBY. Compute natin yung FBY. So, MY, from the previous example, SY over 2, we will have FBY equal to 165.75 megapascal. Now, check for the adequacy. No? Ito lang. So, substitute nyo lang. FBX, FBY. Now, here, ang mangyayari is naging 1.415 yung interaction value. So this is greater than 1.0. So if the tangential load is at the top flange, the beam section will be inadequate. So inadequate na yung section natin. So yun. Example kapag nasa top flange yung tangential load. Naging inadequate yung section natin. Yeah. Ito naman, punta na tayo dito sa design of purlins. Now, yung purlins kasi, actually, it is a member na nagpo-fall sa category ng biaxial bending. Kasi nga, ang purlin natin, it is subjected to a normal load caused by the wind load and then a tangential load sa centroid. Nasaan galing yung tangential load? Kasi di ba yung purlins is inclined, ganito yung itsura niya, no? Kapag inclined siya, of course, yung vertical load, eto, at an angle theta, meron tong, di ba, itong vertical load na to, itong vertical load, meron din niyang component, di ba? Kunyari W, gawin natin tong WY. So, ito naman, magiging itong W sin theta, di ba? WY sin theta. Tapos meron din yung X component. WY cosine theta. Now, if you notice, this a purlin is subjected to both the normal load and a tangential load. So, nagpo-fall siya sa category ng biaxial bending. So, ang analysis po ng Purlins is kailangan nating i-satisfy yung conditions na explain ko earlier. So, kasi subjected siya sa wind load and vertical loads. So, yan. So, ang truss kasi, ang Purlins kasi, di ba, I think if you recall sa first part of our discussion, Purlin is a type of beam. Na kino-consider siyang beam yung Purlin. So yan, Purlin is a typical example of a beam subjected to unsymmetrical bending. Tulad ng sabi ko, no? They are assumed to be simple beams, so simply supported beam with span equal to the distance of the truss. Now, loading consists of wind load acting normal to the Purlin, the weight of the roof, and the weight of the Purlin itself. All assumed to pass through the centroid of the Purlin. So ito yung mga load, no? Yung load or normal load, tulad nung sabi ko, yung wind load plus the x component ng vertical load. And then ang tangential naman is the y component of the vertical load. So naka-sin theta. Now, this is not fixed. Etong mga to, nakadepende pa rin tayo sa given ng problem. Check natin. Okay, so you would need to design yung Purlins nung sa project nyo, no? Yan. So the determination of Purlin size. So approximate section modulus, we have, if not given, ito yung approximate, mx over 0.66 fy, sy is my over 0.75 fy, allowable bending stress along x-axis. Now, assume na section is compact. Diba? This is how we solve kung compact or non-compact. And then allowable bending stress along weaker axis, 0.75 fy. Always kapag bending sa y, we have 0.75 fy. So note, bending along the stronger axis governs the selection of the size. Now we also have sagrads. Now, sagrads usually composes of reinforcing steel bars that acts as lateral support for the purlins and keeps the purlins in proper alignment during the erection until the roofing is installed. The sagrads reduces the moment along the minor axis and are computed as follows. So ito yung moment kapag nagsusolve, no? If the sagrads are at the midspan of the purlins, we have WL squared over 32. Sagrads naman at the third points, WL squared over 90. Again, anong purpose ng sagrads? It reduces the moment along the minor axis. So, kung papansin nyo, this is MY. No? Kasi normally, di ba, kapag simply supported beam subjected to a uniform load, ang moment natin is WL squared over 8. Now, kapag nag-add tayo ng sagrad, kung mapapansin nyo, naging over 32 tsaka over 90. So, generally, mas lumiit yung moment along y-axis kapag naglagay tayo ng sagrad. No? So, yun. Again, ang purpose ng sagrad, nire-reduce na yung moment sa minor axis. Dun sa, ito, explain ko lang yung itsura, no? Lalo dun sa hindi pa familiar. Ganito po yung itsura ng elevation ng truss. Tapos, ito yung truss, no? Ito yung truss members. And then, ito yung purlins, nakapatong siya sa truss. Ito. And then, ito naman yung sagrad na tinatawag. Itong line na to. So, ganyan ang purpose niya, sinusupport niya yung sa ating mga purlins. Now, kung gagawin naman natin na plan view, no? Ito yung truss. So, kung gagawin ko ng line, gawin kong blue line yung truss. Hindi kayo mal na plan view. Ito yung truss natin. Ito. Ayan yung truss. Tapos, yung kanina, no, ang view nyo kanina is nandito kayo. Ito yung view earlier. No, di ba kanina? Nandito yung view nyo. Cross-sectional view yung earlier. No? Balikan natin. Sorry. Ayan. Cross-sectional view siya. So, ito yung view nyo dun earlier. Ito naman yung top. And then, ang ating purlins, itong mga to. Ay, sorry. Ito yung purlins natin. Ayan, itong mga to. Purlin sa left side, sa right side, left side, right side, etc., etc. And then, ang ating sagrad is itong, saglitan ko na. Ang sagrad natin is ito. Yung nagko-connect sa mga purlins. Kasi ang purlins natin yung red line. Ito yung purlins na. Yan. Now, yung example na to, yung figure na to, this is an example of sagrad at the midspan. Kasi ito yung purlin, no? Ito yung purlin, tapos may isang sagrad lang siya sa gitna. So, this is an example of isagrad located at the midspan of the purlins. So, kung papansin nyo, ang length ng isang purlin is the distance of the truss. Diba? Ito yung truss 1, truss 2. Yung haba nila, that will be the length of your, yung distance nila will be the length of your purlins. Okay? So, yun. So, ano pa ba? Ayan. So, again, it's important that you understand the sections. So, yan. Okay, so example. Select a W section to serve as a purlin between roof trusses spaced at 4.6 meters on centers. Assume all loads passes through the centroid of the purlins. Spacing of purlins is 1.4 meters on centers. Assume that the purlins are fully laterally supported and subjected to the following. So first we have, ito daw yung load na i-carry ng purlin. No? We have the snow load, yung weight ng roof itself, and then the wind load. Now, the slope of the truss is 1 vertical to 2 horizontal. Sagrads are provided at the midpoint of the truss. So, FY 248, and then select from any of the W section. So, design to. Magdi-design tayo ng truss. Magpipili tayo dito sa tatlo if alin yung safe and economical. Of course, paano mo malalaman yung economical? Kung safe tong tatlo, we need to choose the smallest purlin. Of course, syempre yung smallest purlin, no, yun na yung pinakamura sa tatlo. So first, check for the safety nung pinakamaliit. So kung magta-try tayong mag-compute, uunahin natin tong W6 by 8.5. Now, if in case no, pag-solve natin later and then maging safe na siya, you don't need to compute for this two kasi of course, kung safe na siya sa mas maliit, definitely mas safe din siya dito sa dalawa. So, ganun yun kapag pag nagdi-design tayo or nagko-compute kayo, and then you have 3 options. Always start with the smallest. No? And then yun. So, let's start. So, ito yung given load. So, before tayo try mag-design or try mag-choose, kailangan muna natin i-compute yung loads. So, we have snow, roof, and wind surface. So, yung snow, that is a vertical load, considered as a vertical load. No? Roof is a vertical load. Yung wind surface, that is a normal load or normal siya dun sa direction ng purlin. Tapos, yung truss daw, space at 4.6 meters in center. Spacing ng purlin, 1.4. And then we have the slope, 1/2. So, example lang to, no? Kasi i-visualize lang natin. Yun. So, ang slope ng truss is 1/2. So, ito na yung slope. So, paano ba? Kailangan kasi ma-visualize nyo siya, no? So, yung spacing daw ng truss is 4.6 meters. So, I will be using the same figure that I used earlier. So, kung sakaling ito yung ginagamit natin na truss, no? Yung 4.6 na tinatawag, ito yon. Ito yon. Spacing siya nung truss daw. So, 4.6. Spacing ng truss, sabi niya. Tapos, ang spacing daw ng purlin is 1.4. So, ito yan. Kasi ito yung purlins natin, no? Diba? Ito yung purlins. So, ito yung spacing na 1.6. Ito yung 1.6. Yan. Spacing siya ng purlins. Now, yung slope, ito, yan. Yung slope or angle nitong truss natin is, Ayan na, 26.6 degrees. Yan. So, ito yung, para saan ba to, no? Para saan siya? We need the angle to get the x and y component of the vertical loads. No? Kasi di ba if ito yung Purlin natin, example ito na. Yung vertical load will have the x and y component para malaman natin kung sa normal or tangential uniform load natin siya ilalagay. Natin. Yan. So, paano naging ganito yung computation? Since ang binigay sa atin is Newton meter square or surface area, if you recall, sorry, this is 1.4, no? Hindi 1.6. Gawin ko lang ito, 1.4, sorry. 1.4. Ito, yan, 1.4 to 1.4. If you recall in your structural theory computation of loads, ang tributary area, kapag ganito, di ba, this is 1.4, 1.4. Siyempre, i-analyze natin is isang Purlin lang, hindi yung lahat. So, for example, ito yung Purlin na kinoconsider natin, ayan. Ang tributary area is half and then half. Di ba? Ganun yung pag-compute natin. If you recall, half, di ba? Tapos, ito yung area ang i-consider natin, di ba? Ito. Now, if this is 1.4, so this side here, this is 0.7, no? 0.7, tapos 0.7. So, ang tributary width nung isang Purlin natin is 1.4. Now, since this is surface area, kapag nagko-compute tayo, what we need is a uniform load. So, we need to convert this into a uniform load. So, kung baga, sabihin na natin, ito yung Purlin, no? Tapos, sorry, ito yung kinikerry niya, no? Ito yung 1.4. Now, since surface area yan, hindi naman tayo nag-compute ng ganyan. I-convert natin yung surface area, kasi surface area yung ganun yun, di ba? I-convert natin siya ito a uniform load, di ba? Kung gawin natin itong 3D, gawin natin 3D na. Ito yung C. I-convert natin yung itong load na to into a uniform load. I-convert natin siya into a uniform load na kilonewton per meter. Now, how do we do that? Since this is Newton meter squared, all we need to do is multiply it with the tributary width para maging siyang uniform load. Kaya ang ginawa, ito, 1,400, di ba? 144 Newton meter square times 1.4 meters. Di ba? Makakancel yung meter. We will be left with Newton meter. So, uniform load na siya. Di ba? Recap lang to ng computation of loads. So, I hope that's clear. Yan. So, ang ginawa natin is, we multiplied all the loads kasi lahat sila naka-surface area or naka-Pascal. Convert natin sila into a uniform load. That's why we multiplied them into the tributary width of a single Purlin. No? Ang isang Purlin, ito yung tributary width, multiply natin para maging siyang uniform load sa gitna. So, for the snow load, a single Purlin is subjected to 2.1 kilonewton meter. Ang roof naman for 0.4 kilonewton meter. Ang wind, 1.08 kilonewton meter. And then, weight of the Purlin. So, bakit siya 150? Saan ko nakuha yung weight ng Purlin? Actually, in-assume lang po since wala pa naman tayong. Since this is design of Purlin, dito lang ako nag-base. No? Ito yung typical weight ng Purlins natin. So, 124, 175. Since nag-design tayo, no, we don't know pa kung alin yung gagamitin. Nag-assume lang ako ng weight ng Purlin. Ginawa kong 150. Assumption lang siya. Kasi design kasi to. Nag-design tayo. So, of course, we need to include the weight of the purlin itself. So assuming na ang weight ng purlin is 150 Newton per meter, add natin lahat ng vertical load, di ba? Ang vertical is yung snow, roof, and then yung weight ng purlin. So the total vertical load is 2,569.2 Newton meter. How about the tangential load? Meron tayong wind load. Pero hindi pa to final because this is vertical load. Meron tong X and Y component. So tingnan natin. Ayan. So kung isusulat natin, sulat natin siya. Yun. Diba? We have this total vertical load. Andito yan. Siyempre dapat straight line. Ayan dyan. So ito yung ating 2,569.2. Tapos yung angle na to nakuha na natin earlier. Ayan, 26.6. Itong angle na to. That is 26.6. Siguro na. Gawin ko na lang siyang theta. Theta. And then, naka-given na din dito. Ayan. Given na dito yung una, ang ating, nandito na yung wind load natin na 1,008. So, sorry, 1,008 na. So, we have 1,008. So, ano pa yung additional? Because since this is a vertical load, kukunin natin yung component niya. So, ang component niya is, di ba, yan, sorry. Ang component niya is dito, di ba? And then dito. Ito, cosine, di ba? Cosine is ito. Ito yung cosine. Yan. Cosine, di ba? Ang sine is the opposite or ito, no? This here is the same with this one. No? Kung nako-confuse kayo, recap please yung angles and values, no? So, yun. So, this is 2,569.2 sine theta. Then, 1,008 plus 2,569.2 cosine theta. Bakit? Kasi diba, kapag nag-compute, what we need is your WX and WY sa along the normal and the tangential axis. So, yan. So, all you need to do now is add. So, tingnan natin. Ayan na. So, we have 1,008 plus 2,569.2 cosine 26.6. WY is the Y component of this vertical load. So, 1150.4 Newton meter. So, ito na yung uniform. If you notice, naka-uniform load tayo, no? So, this is the uniform load that a single purlin will carry. Then, check natin. Now, since meron na tayo nito, we can now design the section. Yan, so copy ko lang yung loadings. Then, first is yung moment along x-axis. So, WL squared over 8, since uniform load to, and then we are assuming na ang purlin is simply supported. So, WL squared over 8. Now, yung WY natin, according to the problem, may sagrad siya at the midspan. So, kapag may sagrad sa midspan, that is WL squared over 32. Sagrad at the midspan. So, yun. So, your MY will be 760.7 Newton meter. So, again, ito yung WX and WY na na-compute natin earlier. And then, para nasa na yung moment, i-check na natin yung adequacy niya sa unsymmetrical bending. No? Since, again, yung purlin natin is just an example of biaxial bending. No? So, ang analysis natin for the adequacy of purlin is the same lang dun sa previous example. So, for us to check kung safe ba siya, ito yung gagamitin natin na equation. So, dito tayo magbe-base. So, first is, i-compute muna, check natin kung compact ba siya or hindi. So, paano natin naman check kung compact o hindi? Pipili muna tayo dun sa sections. Dito sa tatlo, sabihin natin, let's try na since meron na tayong load, ito yung load na i-carry ng Purlin, pipili na tayo sa section kung alin ba yung safe. Try muna natin yung pinakamaliit. Let's say W6 by 8.5. Given yung properties niya, ito, XXSY, tapos given yung properties, check natin kung compact o hindi. So, ang BF nito is 100.076 over 2TF. Ang TF niya is 4.928 times FY. So, we have 159.82 less than 170. So, the section is compact. Now, since compact siya, ang gagamitin natin na adequacy ng bending is ito, no? Ito ulit. Sorry. So, ang gagamitin natin is ito ulit. Yan. Kasi compact yung section. Now, how do we compute yung FBX and FBY? Diba? Babalik tayo. FB is MC over I or M over SX and SY. Meron na tayong moment. Ayan na. So, meron na din tayong SX saka SY. So, mabilis lang ma-compute yung FBX saka FBY. So, substitute na lang yan. Here. So, yun. So, compute the actual bending stress along x-axis, bending stress along y-axis, and then substitute. Now, here, if you notice, yung interaction value natin is 0.89, less than 1.0, so the section is safe. So you don't need to check the second and third option because yung smallest section niya is okay na. So in this problem, ang gagamitin natin na Purlin is the first option, W6 by 8.5. Since okay na siya, safe siya for the given loading. Okay, so that will be my last example for the Purlin.